Hello everybody. Today we are going to start Clairaut's equation. So, a equation is given, say y is equal to px plus function of p, where p is dy by dx. So, if any function is given in this form, then this is known as Clairaut's equation. This is known as Clairaut's equation. Then what we do, we differentiate, say it's equation 1, differentiate equation 1 with respect to x. What we get? Dy by dx, we know dy by dx is p, so we write here p is equal to it is u into v form, so first of all differentiation of x is 1, so p plus then leave x and differentiate p, then it is dp by dx plus this function is what? F dash p and dp by dx. So from here what we get? This p and p term is neglected, means it is cancelled. Then we can write here x dp by dx plus f dash p dp by dx is equal to 0. From here we can take common dp by dx, then we get x plus f dash p is equal to 0. So from here what we can write? We can write either dp upon dx is equal to 0 or x plus f dash p is equal to 0. So from here what we get? We will integrate it to the both side, then we get p is equal to c from this relation, and from this relation we will put this value of p in equation 1. Then what we conclude? Put value of p in equation 1. We get y is equal to cx plus function of c. This is what? This is the solution of the Clairaut's equation. This is the solution of the Clairaut's equation. When we solve this form and replace p by this form, then what happens? We get singular solution. From here we get singular solution. Means from here we will calculate the value of p and substitute the value of p in equation 1, in the required equation 1, say this equation 1. Then what we will conclude? We will get a singular solution. So let us see one problem related to Clairaut's equation. More concepts will be cleared from this portion. So let us see. The question is, solve p is equal to sine y minus xp. As we can see here that y is here, so first of all we need to change this form into the Clairaut's equation. Then what we will do? We will take sine to this side, then sine inverse p is equal to y minus xp. So from here we get y is equal to xp plus sine inverse p. So now this is the Clairaut's form, say equation 1. This got Clairaut form. So this is the Clairaut's equation for this problem. So if we write directly, then what we will write for its solution? That we will change p with c. So we get y is equal to cx plus sine inverse c. This is the required solution of the equation. Now to find the singular solution, what we will do? To find its singular solution, first of all, we will know its roots. There will be two roots. One will be of dp by dx. Let us solve that. Then it will be more clear. So differentiate the equation 1 with respect to x. What we will get? Dy by dx is equal to p plus x dp by dx plus, then differentiation of sine inverse p is 1 by root under 1 minus p square. Then differentiation of p is dp by dx. So from here we know that dy by dx is p, then p and p term is cancelled. Then what we can write? We can write here that 0 is equal to, taking dp upon dx common from both sides, so dp upon dx, then we will get here x plus 1 by root under 1 minus p square. So from here let us see in the next page. So we got two roots, dp upon dx is equal to 0 or x plus, what we got, x plus 1 by root under 1 minus p square is equal to 0. So we got two roots. This root gives what? P is equal to c. So from here we got the required solution of the differential equation which is Clairaut's equation. Then from here what we conclude? We will calculate the value of p from here. Then we will put the value of p in the equation 1. So let us calculate it. So we can write here what? X is equal to minus 1 by root under 1 minus p square. So from here what we can write? Minus x is equal to 1 by 1 minus p square to the power half, and it will go, half will go this side, then it will become square. So x square is equal to 1 by 1 minus p square. 1 minus p square is equal to 1 upon x square. So from here we can write p square is equal to 1 minus 1 upon x square. So from here we get p is equal to root under 1 minus 1 upon x square. We got this value of p here from this second root of the differential equation. So from this we will put this value in equation 1. Then what we will get? We will get the equation was what? Sine inverse p is equal to y minus xp, and y is equal to what? The equation is xp plus sine inverse p. So putting the value of p, this value, and y is equal to x into 1 root under 1 minus 1 upon x square plus sine inverse root under 1 minus 1 upon x square, which is the required singular solution. It is the required singular solution of the given Clairaut's equation. So from here we can conclude that we can calculate the general solution as well as singular solution of the given Clairaut's equation. The method is that if the form is of dp by dx, then we can easily calculate that substituting the value of p as c. Then the second root, which does not contain dp upon dx, then from here we can calculate the value of p. From here we can calculate the value of p and put that value in the equation 1, and that relation will give us the singular solution of the given Clairaut's equation. So now this question I think would be clear to you. Now we are going to see the equations reducible to Clairaut's form. So let us see that. We can easily reduce any first order higher degree differential equation into Clairaut's form. Let us see this problem. we can easily conclude about the given situation that equation reducible to Clairaut's form. So let us see. The given problem is this: px minus y into py plus x is equal to a square p. Now here we will put x square is equal to u and y square is equal to v. From here we get 2x dx is equal to du, and here 2y dy is equal to dv. So from here we can get p is equal to dy by dx, which is equal to dv upon dy upon du upon x, not dy, dv upon y, is equal to x upon y into capital P. We considered capital P is equal to dv upon du. Here यहाँ पर हम लोग ये कंसीडर करते हैं ऐसा. So now what we can do, that we can put the value of a small p this, then now put a small p is equal to x by y into capital P in equation 1. In equation 1 we get what? X upon y into capital P into x minus y, then x upon y into capital P into y plus x is equal to a square into x upon y into capital P. So from here we can get x square P minus y square upon y into, here y cancel, so xp plus xy upon y is equal to a square xp upon y. So from here y and y cancel, but here remains 1y because it is y into y square. So from here we can put the value of x square as u and y square as b, as we have considered here. So let us put that value here. So we get u capital P minus v capital P plus 1 is equal to a square capital P. So from here we can write u capital P minus v is equal to a square P upon P plus 1. We took it here this side in division. So from here we can write v is equal to up minus a square P upon P plus 1, which is the Clairaut's form, As we can see that this result is similar to the Clairaut's equation, as we have read y is equal to px plus function of p. This was our Clairaut's form, and this equation which came here is similar to that. So this is the required Clairaut's form. Now if here tells that we need to calculate the solution of this Clairaut's form, so we will simply substitute the value of p as c. So we get here v is equal to uc minus a square c upon c plus 1, which is the required solution of the Clairaut's form. Now it is clear to us, to everyone. So you must do some problem related to this. I am giving you here a problem. You can write this problem question: y plus 2 dy by dx whole square is equal to x plus 1 dy by dx. One more problem: x square y minus px is equal to yp square. So if you like my video, Please subscribe and share it, and do these problems, and I will give you more problems related to this, and we will discuss also the problems in next upcoming lectures. So please like and subscribe it, and if any doubt please comment in the comment box.